Okay, we're going into a new chapter, chapter 7. It's called Systems of Equations. So this is where we have, instead of just one equation that we're trying to solve for, where we have a system or multiple equations that we're going to be solving for. The first section that we're going to do is we're going to do solving systems of equations by graphing. So we graph each equation, and where those two equations or where those two lines intersect, that's where they share solutions. So that would be the solution for the system. I'm going to show these by doing two-story problems because I think real-world problems will bring a better understanding to why we're solving these and how they're applicable to the real world. So, you and a friend go to Taco Bell for lunch. You order 3 soft shell tacos and 3 burritos, and your bill is $11.25. Your friend's bill is $10 for 4 soft shell tacos and 2 burritos. How much do soft tacos cost? How much do burritos cost? So, soft tacos is something I'm trying to figure out, and burritos is something I'm trying to figure out. So I'm going to label soft tacos as my X value. I don't know what they cost. And my burritos as my Y value. I don't know what they cost. So X is the dollars for soft shell, for soft tacos, and Y is going to be the amount of money for the burritos. And you'll notice what they did there is they gave us 2 different pieces of information. They gave us 3 soft shell tacos and 3 burritos. So 3 soft shell and 3 burritos. So 3 soft, 3 burritos. So for that first person, friend 1, all right, we'll just call this friend 1, I have this equation that would be 3 soft shell tacos times the cost, X, plus 3 burritos times their cost, which is Y, is going to equal the total cost that he paid, which is $11.25. And then I have a second equation which said that this friend, his bill is $10, all right, for 4 soft shell tacos and 2 burritos. So 4 soft, that means I've got 4 soft shell tacos times X, which is the amount that they cost, plus 2 burritos times Y, how much they cost. And that equals, he only spent $10. So you see, in this first equation, typically we would solve this equation, we try and figure out what X or Y is. But because we only have one equation, and we have 2 variables, there's no way for us to just use this one equation to figure out what X is and to figure out what Y is. Because we can isolate X and we can isolate Y, but we won't get a number. We won't know what the cost for the soft shell is or the cost of the burrito. And the same thing's true for this equation. All right, we don't know X, we don't know Y. It's one equation, we can't solve for it. But if we have 2 equations, and we have 2 variables that are the exact same, so X is the same, means the same thing in both equations, Y means the same thing. 2 equations and 2 unknowns, we can actually solve and figure out what the cost for X is and the cost for Y is. All right, and we can do it using different methods, but the method we're using this time is graphing. So what we're going to need to do is we need to graph this equation. If I want to graph this equation, you'll remember you want to put this in slope-intercept form. So I left a little room here so I can work. Slope-intercept form means to solve for Y. So I'm going to subtract 3x from both sides. And that gives me 3y equals negative 3x plus 11.25. And now I'm going to divide by 3. I've got to get y by itself, so I'm dividing by 3. And that's going to give me a new equation, which I'm going to write right here, which is y equals Negative 3 divided by 3 is negative 1x. 11.25 divided by 3, let me put that in the calculator. 11.25 divided by 3 is 3.75. So this is my equation right here, and I can graph that thing. 3.75, if I go up to 3.75, that's 1, 2, 3.75 would be right here. That's my y-intercept. Down 1 over 1, so down 1 over 1. I'm going to go down 1 to here, over 1, mark it right there. I'm going to go down 1, over 1, mark right there. Down 1, over 1, mark right there. And I'm going to do that until I get enough points to where I could graph this thing relatively close to what it should look like. And now I go to this other equation. So this is the graph line. This represents the the relationship between the soft shell tacos and the burritos. So I want to do the same thing here. I want to get this in slope-intercept form. So I want to solve for y. So I'm going to subtract 4x. Subtract 4x. That gives me 2y equals negative 4x plus 10. Now I'm going to divide by 2 to get y by itself. So y equals negative 2x plus 5. Now you'll notice two different equations. All right, I'm going to graph this thing. This has got a y-intercept of 5, which would be right here. It says down 2 over 1. So I'm going to go down 2 from here, 1, 2 over 1. Mark it. All right, now you'll notice they're not touching. All right, so I'm going to go down 2 more, 1, 2 over 1, and mark it right here. Okay, and then if I go ahead and solve, or I go ahead and graph this, you'll see that right there is where they intersect. So at this point right there where they intersect, we have a solution. All right, they share this solution. So this would be the answer to our equation. All right, whatever that coordinate is. So whatever the x value is, and whatever the y value is. So whatever the x value is, and whatever the y value is, that's going to tell me the cost of my soft shell tacos, and this will tell me the cost of the burritos. So this is burritos, and this is soft shell. So all I have to do is look at this spot here and see where's it at. Now, is this going to be exact? No, it's not going to be an exact science here because we're not landing on a specific point. But when you guys do your problems, most of the time, you're going to have an exact spot where you're going to be able to look and say, okay, that's the spot. So for us, the x value would be about 1.5. So it's about $1.50 here. All right, and so $1.50, and then it's up. It's about $2.50 there. $1.50 and $2.50. Now we could check our answers and plug them back in to the equation to check these out, but this would be our solution right here. So if we were to answer this question, we would say x, or the cost of the burritos for the soft shell, is $1.50. And the cost of the burritos is $2.50. Or at least pretty close. That's what it would be. So we could check that out and make sure that that's true. Right now, I actually don't think those two numbers are completely correct. But based on how we do it with graphing isn't necessarily going to be perfect. But based on our graph, that's roughly what the cost of those two things are. Okay, now we're going to solve just a regular old problem. We've got two equations and two unknowns. So we just did a story problem. Now we're just going to practice how to put these in slope-intercept form and graph them on the graph and then find where they intersect. So these ones should work out nicer than the story problem was. And you'll see that where those two lines intersect, there's a coordinate that we can use that's a solution, and then we can check our answer. So we're gonna go through and we're gonna solve this one and this one. We're gonna put them in slope-intercept form. So we're gonna add x to each side. That's gonna give us y equals x minus 7. So this has a slope of 1. Remember, 1 over 1 in front of it, and a y-intercept of negative 7. So negative 7 is right down here. Up 1 over 1. Up 1 over 1. Up 1 over 1. So we can graph that line, and we're just going to keep going. That way I make a nice straight line. So if I make this nice straight line here, that is the equation. This is the line for this equation here. So now let's do the same thing here, and let's put this in slope-intercept form. So we're going to subtract x. So 4y equals negative x minus 8. Now we have to get y by itself, so we're going to divide by 4, divide by 4, divide by 4. That gives you y equals negative 1/4, because remember there's a 1 in front of the x, negative 8 divided by 4 is negative 2. So we go to negative 2, and that's our y-intercept. It says down 1 over 4. Down 1 over 4. 1, 2, 3, 4. Oh, look where we landed. Right on that other line. Down 1, 1, 2, 3, and then it would be right out here. So let's draw this line. So you can see that these two lines intersect at this point here, which means the only solution, remember all these spots on this line are solutions, and all the spots on this line are solutions for that line. Well, wherever they meet, that's the only solution they share. So the only solution they share between these two lines is this one right here. So this has to be the solution for the system of equations. So we're going to write down that coordinate. That coordinate, remember, it's x first, so 4, comma, negative 3 is supposedly our answer. So I think our answer is 4 comma negative 3. I want to check it to make sure. So take it and plug it back into the original equation. So remember, this is x and this is y. So 4 goes in for x, so it's a negative 4 plus negative 3 for y equals negative 7. Negative 4 plus negative 3 is negative 7. Boom, that works. So we got to just check it with the other one now. Let's take this and plug it into the other equation. If it works, we know it's a solution for both. So 4 goes in for x, so it's 4 plus negative 3 goes in for y, so it's 4 times negative 3 equals negative 8. 4 times negative 3 is negative 12. And 4 plus negative 12 is negative 8 equal negative 8. So yes, that works for that one too. So this is the solution for our system of equations. So you can see, you just put it in slope-intercept form, put this one in slope-intercept form, graph them both wherever they intersect.